All right, well, let's get started. Hey, Craig,
Hi.
have a seat.
Hey.
The Brian Shrimp Cooperative is over at the other building.
Oh, really?
You did say several times it's different. Were you over at the other building too?
You know, I'm a speed reader.
You were over there. Because when I speak, you guys. Well, good. Well, we've got some folks online and a room full here. So why don't we? Oh, here they are.
Sorry about the
Change the venue. Yep.
change of venue.
Serves us right for not taking.
Here.
Well, let's just go around the room just so this camera system is great, but I think it's good for everybody who's online just to, if you can say your name and who you're with, I think that would be great. Bonnie or Jennifer, would you like to start? Sorry, I can't use your mouth.
Sorry, I'm Jennifer Biggs. I'm with the Division of Forestry Current Status.
Bonnie Baxter, Great Salt Lake Institute, Westminster College.
John Luck, Division Wildlife. Kyle Stone.
Mark Reynolds here for Tom Tripp, US Mag.
Bill Johnson, Utah.
Andrew Ruffy, Utah Geological Survey.
Thomas Goldsteel, Gresham Cooperative.
Christine Rumsey, USGS.
Or Vernon Forestry Fire and State Lands.
Craig Miller, Utah Division of Water Resources.
And Jeff DenBleyker with Jacobs. And
Bill Brown, Gresham Cooperative.
Wade Wallace, Brown Trip. Great. And then online, I see Ryan Rowland, Jim Harris, Krishna Khatri, and I think Christine's got her computer on, and I do too. So, anybody else I missed? Great. Well, appreciate everybody coming today. There's obviously a lot going on the lake, and salinity is, I think, at the top of many people's concerns with the changes that we're seeing in the lake. And so I think I'm glad we're having our meeting today, and we didn't postpone until November. But in terms of our agenda, what I wanted to focus on today was just looking at update on salinity conditions. I know Ryan couldn't make it into the room, but he and Christine will tag team that. I would like to kind of open the table up for everybody, other observations that people are making out in the field and changes on the lake. And then the kind of the focus of the meeting today, what I want to do is really try to revisit the research question. I sent this out to you all, and I appreciate the responses I got from people. The goal here is we want to try to perhaps reprioritize or what work needs to be done sooner rather than later. And so that's I'm going to kind of distill the questions or the comments I got from folks, and then I'd like to talk through those with you all to identify, I guess really what I'd like to do is update our research and monitoring plan. So we can use that to try to find additional funding or, refocus our efforts if we need to. And then, of course, if there's any other salinity related issues, and try to identify some action items. I did send out as part of the package to you all the meeting summary from our last meeting in August. And were there any comments on that or any changes you want to make to that? If not, I think have a motion to approve the meeting summary from the past.
Motion to approve.
Second. All right. Thank you. And then all those in favor of approving them?
Aye.
Any opposed or have any questions on them? Or online? Yes, hearing none, we will finalize the meeting summary then. Just so you all know, we are being cast live on YouTube. We have a Salinity Advisory Committee YouTube channel now, and so our meetings are now on there, and so recordings are there, so people can easily access them. Just so you all know, we're online. So
Jeff's kid is bummed that Jeff has his own YouTube channel before he does.
yes,
Right.
yes, my 12-year-old had told him he couldn't have one until he's 13, and so. So anyway, yeah, he's upset that I'm online first, but neither here nor there. So I guess first of all, like, just turn it over to Ryan and Christine. Just an update on salinity conditions out there. I'll stop sharing view.
All right, so Christine and I are, like you said, are going to tag team this. So somebody hopefully there has the presentation queued up.
I'll share it, right? I'll share my screen.
Okay. I have COVID. That's why I'm not with you guys today. This is round 2 with COVID, and it's good stuff, man. Having fun. Okay, so Christine's got the slides queued up now, so we're just going to cover kind of our usual briefing, so just a little bit on lake elevations, and some information on discharge and velocity data. I'm also going to talk a little bit about inflow volumes to the lake to give you a summary of water year 2022. Next slide, please. All right. Well, so we have a gauge at the Great Salt Lake Marina, and it's got that long-term record associated with it all the way back to 1847. And you know, as you all know, we broke the all-time low record value in July of this year. But if you go to that gauge now and want to look at current data, you're going to see that the data at that site ends on September 23rd, 2022. And at that time we had a reading of 4189.0, and that is because there's now not enough water at this location to produce good data. And I think if Christine hits the next button, you will see a picture of what conditions look like at our gauge. So that thing up there at the top is our down-looking non-contact radar sensor, and that stuff down at the bottom near the dock, closest to the dock, is mud. So this is causing issues with our data quality here, and so this site is no longer providing data at this time, and we'll resume data collection in the marina once it's dredged, and then, you know, we're optimistic too that water levels will come up to a point where we can reactivate this site. For right now, though, if you want up-to-date data for the south half of Great Salt Lake, you have to get data for an alternative site, which is station number 124, and that's located on the southern side of the railroad causeway, just east of the new breach. That was installed several years ago by Mike Freeman and others here at USGS, and so real-time data for that gauge are available. So if you hit the next button. So here I'm showing average daily values logged at this site going back to early September. We see the downward trends since early September, and currently we're sitting at, or at least as of yesterday, the average daily value was 4188.8 feet. And that's an overall 2.6 foot drop since the max elevation of the South Arm in April of this year. And hopefully things level out. Hopefully we're getting there. It's awfully warm. There's not much flow coming towards the lake right now. So, and just to put that 2.6 foot number in context, last year we dropped about 2.8 feet between April and mid-October. So we are looking very much like we did last year in terms of how much the lake dropped. And actually how much the lake increased in response to spring runoff earlier this year. Very similar behavior. Next slide, please. Okay, so how did we do with our major rivers? So here's the cumulative flow plot for the Bear River near Corinne. We have cumulative flow in millions of acre feet on the y-axis. It's a log scale. And then we have a water year on the x-axis. The bold black line is water year 2022. The shaded green area is the delineates the 25th to 75th percentile range. That little gray line in the middle of the green is the median. And then the blue is the highest ever measured cumulative flow, and the orange is the lowest ever measured cumulative flow. And we didn't do that great, right? We're well below the 25th percentile. We did not have a great year at the Corinne gauge. We didn't even make 1 million acre feet, which would have been absolutely fantastic. That would have put us in the green zone. So that's the Bear River at Corinne. So we're going to kind of cycle through the next 3 sites, and then we'll do the overall math. So here's Farmington Bay outflow at the Causeway Bridge, same type of plot. The bold black line, just note it's well outside the green shaded area, the 25th to 75th percentile. So we were below what we'd consider normal for this site. This site, it has a limited record, 10 to under 20 years of record at this site. The last site has many more years of record, by the way. You'll see that at the very top of the plots there, just to give you a sense of how many years of record are going into those statistics. But anyway, we're below the 25th percentile at Farmington Bay outflow. Next slide, or excuse me, hit next. Here's the Weber River near Corinne. We had not a very good year again here at the Weber River near Plain City. I've taken a lot of the cold medicine today, so I'm a little bit out of it. Weber River near Plain City, right? Okay, so the bold black line is really close to the orange line, the lowest ever cumulative flow at this site. So a very poor water year for the Weber River near Plain City. Next. And then we'll wrap up. Here's Goggin Drain near Magna, Utah. Hey, the bold black line is just below the green shaded area, just below the 25th percentile. So maybe a little bit better at this site relative to last year. I'm not showing last year, but if my memory serves correctly, we're a little bit better at this site relative to last year. Now, if we just total all these flows, the annual flow for all these sites, we get a number 779,000 acre feet for water year 2022. 779,000. Previous water year, if you hit next, 708,000 acre feet. So we are slightly improved over last year. But as you saw with the lake elevation gauges, I'm not talking volumes of water from Great Salt Lake, but let's just talking lake elevations. The lake dropped quite a bit. It did not come up much, and it still dropped quite a bit this year. So this 779,000 acre feet didn't get us very far. We still lost a substantial amount of water out on the lake. Next. All right, just putting these numbers in a little more context. Here I'm showing the average annual flow passing all 4 of those gauges in acre feet on the y-axis, and then the data for the various gauges are shown and defined inside the plot. So the blue area is our data for Bear River, Corinne. Green is Weber River. Light green is Farmington Bay outflow, and Goggin Drain is shown in the light bluish color. And so these are just the total volumes of water passing the gauges each year going back to 2008. And so I've added 2022 to the far right of the plot. So you see 2022 is slightly better than 2021, but very poor overall. And then on this plot, I have the average volume of water passing these gauges. And this is based on the period of record at each gauge. This isn't just this period of record, 2008 to 2022. This is the period of record for each gauge, the average amount of water passing that gauge. Sum those up, so the 4 different sites. That number is close to 2 million acre feet. So anyway, this just is to reinforce kind of the deep hole that we're in, the water deficit that we're experiencing out on Great Salt Lake right now. Next slide, please. Okay, and as everybody knows, we're making monthly discharge measurements at the new breach, and you've all seen this plot before. It's just updated with some of our more recent data. Just to remind everybody, the blue circles are south to north discharge. The red circle is north to south discharge. The light gray line is the difference in elevation between the north and south arms of the lake, and that's based, that's actually based on the saline gauge and salt air. The data don't run out to September or past September 23rd on this plot, when the salt air gauge was discontinued. This is just to give you a sense of the very good scope of this data set. There's not a lot to say at this 10,000 foot view, other than when you go out to the more recent data, you kind of see the blue circles dropping off to lower values, and the red circles have stepped down, and they are also much lower values relative to data, say, between 2018 and now. So if we hit the next button, or hit the next, bring up the next slide. Here we're just zooming in on some of the more recent data then. So this is discharge in cubic feet per second on the y-axis, and we are showing data out to November of 2020 to the most current measurements. And so the first thing to note is the light gray line, the elevation difference between the north and between the south and the north arms. You know, as of July 2022, that elevation difference has dropped off significantly. So now we're at about 1/10 of a foot, whereas in the past we'd be 4/10 to 5/10 of a foot elevation difference. You see how the blue circles, that's the south to north flows, they have dropped off. They're now in the 300 CFS range. Especially some of that more recent data around July and August 2022. And then the red circles for the north to south flow direction, those discharge values have also dropped off significantly. And since that new, since the berm was raised 4 feet, those values have dropped off from, you know, somewhere there in the 100 to 200 CFS. Now they're down in the 10 CFS range. And most recently, the most recent value, the red circle there, is actually 0. There was no measurable flow moving from north to south, and at least according to the instruments that we were out there using to make the measurements. So, and so that's, you know, the data from July 2022 and onward. This is a reflection of the impact of raising this berm, where those north to south flows have dropped off significantly. South to north flows have also slowed down quite a bit, but they're much larger than the north to south overall. Next slide. Okay, so this is a slide, a plot I put up during our last meeting. So this is data from our Uplicker velocity meter at the new breach. It's on the north side of the bridge. It's on the bottom of the lake looking up. It's measuring velocities at 10 depths in the water column, and each line on that plot is velocity data from one of the depths. And so we have velocity in feet per second on the y-axis. Anything that's negative is north to south. So negative velocities are north to south. Positive velocities are south to north. And so we have data from July 2020 out to August 3rd or 4th or 5th. The point of this plot is just to show how we had fairly significant positive and negative velocities. So flows in both directions when the new berm was constructed. In the latter part of July, you see how those velocities dampen off, especially those negative velocities dampen and trend close to 0. And then we still have some positive velocities, you know, in the 1 foot per second range. So this is a direct impact of raising that berm. This is just really cool data, and I just want to emphasize the instrument is still there and it's still collecting data. So if Christine hits the next button, Here we see all the data collected essentially since July of 2022, when all the activity was happening, raising the berm during the latter part of July, out to current. And you see the overall picture still holds, where the velocities, both north and south, have dampened off significantly in response to the berm being raised. But we do see some significant negative velocities. They occur in this data set, and these are likely just in response to wind events out on the lake. And so if we go to the next slide, we'll just kind of zone in a little bit on an event, or a series of events in late September and through early October. So it's the same type of plot. All the colored time series lines represent different depth velocities at different depths in the water column. However, I've added in wind speed. It's the gold dash line, and the axis for wind is on the right side of the plot in miles per hour. And you can just see as wind speeds amped up around September 29th. We saw velocities jump into the all positive range and relatively higher positive velocities. But as we move out to the second wind event, so these would likely be winds moving from south to north, so southerly winds pushing water to the north half of the lake. And then if we go to the event where I have wind speed, the wind speed label, we have very, very strong winds that push all of our velocities to the negative, so moving all water from north to south. So this is likely a strong northerly wind event. So the instrumentation is out doing its job, providing the information that we're going to need to refine and finalize that numerical model that Utah State University is working on. So I just want to point out the data are coming in and are looking good. Next slide. Okay, that's it for my part. Christine will take over.
Cool. I just wanted to say that in addition to collecting the velocity data that you've reached, we've been going out sampling with increased frequencies to measure profiles and just see if we can see that north arm water sitting under the bridge, and just kind of monitor how that evolves over time. And
Christine, while you have that picture up, well, could you go back to that? On the right-hand side, there's a little seep of pink water that we've noticed that's coming through. Have you seen that? It looks like the berm isn't complete on the right-hand side.
I think it was just a function of how they had to build up the berm, and on the west, they needed a bigger platform because that's where they were using their machines, I think. But from what I can see how you could see that, but I've only been out once, and when I was out there, it looks like it was holding it back on that east side, and it does look like it's complete. It's more narrow. I don't know if others have seen other things.
It looked like it was flowing to me, but I couldn't. Okay, I'm not sure.
Yeah, maybe when were you out there? Because I was out there right after it was built.
I don't know.
I know that our team has noticed, like, when there's even just a slight change in wind direction, you can get some pouring over of north arm water down and toward the south. So it might have been a wind factor there. I'm not sure, but I think it is pretty touchy.
Okay, yeah, that makes sense.
And just as a kind of a simple metric of what we're seeing is just where that interface is. When we go out there, this is the bridge, and a kind of a diagram of the bridge and where we collect our profiles. So we go to the center of the bridge and we collect field parameters every foot all the way down. And what I'm showing in this table is the location of this top of this mixing zone, where we go from south to north flow and then transition to north to south. And so prior to the berm modification, that interface was at 3.5 foot below the surface. And then the day after the berm was modified, we observed that it was 8 foot below, and it's kind of been hovering between 5 and 7 feet. We're still seeing that interface. We're still seeing that north arm water is hanging out there, but as Brian pointed out, it doesn't appear to be moving. It's just kind of maybe just a plume that's sitting there. So I just wanted folks to be aware that we've been collecting that profile data, collecting samples periodically as well, and higher frequency than we normally do, just to track the response of that opening to the berm modification. And if we look at the salinity values, this is what I normally show. Our most recent value that we collected on October 3rd, this was collected by Great Salt Lake Ecosystem Program, was 183 grams per liter. In the lower right-hand corner, I've compared that to data that the USGS team collected last week, and it ranges, and this is from 7 sites in the lake. The salinity is ranging from 180 to 185 grams per liter across the lake. And then Andrew sent us salinities, or sent everyone salinities from UGS samples yesterday that were just north of Saltair Marina, and those are 184 to 185. So that's about where we're sitting with the surface. And then it's this site, and at 3510, we're not seeing the deep brine layer. You're not seeing it at all, right? No, okay. And also at 2565, if we look at the densities, we're starting to see, so that's the site more in Carrington Bay, we're also starting to see that one converge and mix out. So this is indicating to me that the berm is working, because we've consistently seen that deep brine layer in Carrington Bay, and the fact that we can't measure the flow from north to south, and that we are seeing it mix out at 2565 indicates to me anyway that that it is restricting flow, and it is restricting salinity transport. So that's all we had. If anyone has questions.
Yeah, could you go back to that slide about the breach? Just one more back there. I'm just trying to picture where you're measuring that depth of interface. Is that being measured on the south side now of the causeway in those numbers, or is that on the?
It's on the north. So there's the railroad, and then there's the road. If we we lower our instruments on the north side of that bridge, and we have a weight with our sonde, and we just lower it every foot.
South of the berm.
Yes. Oh, sorry. Yes. On
South
the
of the
north side
berm.
sorry. Yes. South of the berm.
Just right.
Yes.
Okay.
Yep.
Good. Okay, that answers my question. Thank you.
I can stop sharing.
Any other questions?
I just want to make a point on an early slide that Ryan showed with the water years. Can you flip back to those water years? Yeah, that one right under.
Okay.
Thank you, Christine. Yeah, the middle of that is the period during which the causeway was closed, if I'm reading that correctly. So those low values. And it's interesting that those were really modest water years, and then we got a 3-foot differential between the south arm and the north arm when the causeway was closed, even in those modest water years.
Yeah.
With recording.
Sure is.
That's a good point.
Yeah, thank you, Bill. That was a good point.
No, another question is, has anybody looked at what the average inflows would need to be to maintain lake levels?
Yeah.
Crab.
Well, but I don't have that information here. I'm sorry.
Okay.
Just have to equal the evaporation, whatever that is. We're not quite doing it.
Just barely. We're definitely not quite doing it. That's pretty obvious, right?
It is, yes. I'm obvious man today, but
I mean, we took a look at that, just looking at historic data, and we believe it's somewhere between, somewhere around 1.7 million acre feet. Be happy to show those data at some point if people are interested. But again, it's sort of very, very preliminary.
That's an
Just looking
annual
at historic data.
An annual inflow.
Annual inflow required to maintain,
4,200.
well, just maintain lake level.
Maintain
where it is
net
today.
zero.
Net zero.
Variation, not sure, but over the long-term average, that's about where inflow correlates with no net change in elevation.
We did have Water Resources give us a number of what it would take to raise the lake level a foot at the current elevation that it is right now. And it was over 600,000 acre feet of water.
That's just 1 year. But if you had a continuous amount of water coming in
you need a little less to do that. So
Even during a drought, hopefully we could still maintain lake levels in the South Arm.
Our farm gets that.
Here's the North Arms.
Can you share that presentation?
Sure.
Okay.
Shall I send it
It's
to
gonna be
Jeff?
on YouTube. You can watch it anyway. But yeah, you can share it.
I'll send it out with the notes. No
See Jeff do
That's your
little
job,
dances.
Little finger prep, brain shrimp.
For the little brine shrimp collaborative cartoon guy.
Yeah, right, backwards.
I remember at our last meeting, there was some questions, when we were looking at that velocity chart, Christine. I think there was some concern that why did the south to north flow drop, berm? And I think when you look at that chart, you can see before the berm went in, we had more, they were higher. I can't say they're significantly higher, but they were higher than they were after that. But the other, what occurred to me when Ryan was showing the differential water surface elevations, that really dropped right at the same time. So I don't know if that's just a coincidental change, and we had a reduction of inflows into the South Arm that caused the North and South Arm water levels to be that much closer. But that is that water surface differential is really what drives that flow to the north.
I'm betting that you'll find that the net flow is about the same. You need to subtract the north from the south.
Well, I think the target was to install that right about the time that runoff stops, so we wouldn't have any of the backflow, coming back in. So I think maybe not a coincidence that worked in our favor, but
Right.
not a total accident.
Right. But I think I guess makes me feel better that the berm isn't maybe potentially cutting off that south flow. It definitely appears to be cutting the north to south flow as intended. But I just remember that was a concern at the last meeting. Any other questions?
Ryan, that the wind direction with that was really effective, and you might throw some vectors, some arrows on there to show the wind direction. It's a nice plot.
Absolutely. I'll do that for the next one. Thank you, Bill.
I looked at similar things for the Farmington Bay Causeway when we had a Farmington Bay, and there's definitely on that wind chart, if the wind exceeds 4 or 5 miles per hour, that's when we started to see that north to south flow start. But I think at least when I was looking at the wind data over at Farmington Bay, there's a duration component to it. So the winds had to be going a certain velocity for a certain period of time before it had enough momentum to push the water, or the water had enough momentum to push it in the other direction. Very similar pattern. Great. Well, thank you both for doing that. Appreciate you doing that every meeting.
Welcome.
So I guess any other observations what you're seeing out on the lake, changes in the last couple months?
Well, we looked for the mystery salt coming through the closed culverts. So
How did you do that?
well, we went out with Christine's help. We got one of her nifty salinity meters and took out Andrew's kayaks, and we had one, and we also took out sample bottles in case we found anything interesting. And we didn't find anything interesting. So what happened is we would go out and we would circle where the old culverts were and try to find high salinity flows through there. And we couldn't find any.
You tried the entire water column, Greg, or?
We were down on the bottom of the one.
Yeah, okay.
So, no, we didn't try the entire one. But we were just down on the bottom. And what has happened also is that the predicted bottom at those spots has risen about 10 feet because of probably the sinking causeway. And so, you can't go down the full depth that you would think that they should be there, because it's pushed up the sediment on both sides of the causeway. So we didn't have to go down very far before we hit bottom, but we couldn't find any high salinity flows there.
Did you see any gradient at all?
Yes, well, they got out far enough in one spot where they got the deep brine layer. And we think we found it. Give us the measurement. No, that's not it. So we found the deep brine layer, but that was about it. Well, and that may be true, but there was an awful lot of sediment between the north and the south arm that would have prevented that. And they had filled in those areas where they had the little kind of claw coming out to protect the culvert flows. That's been really.
And that's probably good news, right?
Yeah.
In today's world.
Yeah, but where's the salt coming from? That's the next question.
Christine, what was the magic missing number?
And I'm afraid to look it up. I mean, because we're just working it again. I mean, we'll get. Can I get back to you on that?
Oh yeah,
I can remember a number. You want me to tell you a number that's probably wrong?
I'm very cheap.
I mean, do you remember roughly what percentage of the annual salt budget, for example, it was? Or it may not. I mean, okay, don't worry about it. Just curious.
Well, we predicted a long time ago that that's not an insignificant blip. And if you can't account for it with a model, you can't predict what will happen in the future. So we're kind of wanting to find out what's causing it.
There has to be a maximum depth at which you could drive that, right? The differential between the north and south.
That could help. But remember back when we had that 3.2 foot difference, if you tried to model it with a higher conductivity, so you'd have more flow come through the causeway, but you couldn't maintain that difference. So there's just very little flow coming through there. Mm-hmm. With even with that difference. Yeah. And so with less difference now, I don't know.
Yeah, that's a good point.
Was it Dave Nass who, and the South Shore, I remember they dragged some cable with a bunch of sensors along trying to look for groundwater intrusion. That's something that we can drag along the causeway to see if there's intrusion.
Ryan, you had an idea, right? With the that someone out of the Midwest, USGS, right? They have like some kind of submarine. Am I getting that right? That can
ISI brand Eco Mapper, underwater vehicle, autonomous underwater vehicle, which it has a YSI multi-probe stuck in the nose of it, and so yeah, they could send that thing, we could do some transects along the causeway, go up and down throughout the water column, along the causeway, looking for some of this north arm water. It's something I think we could do with help. The office that has it is in Illinois. It's the USGS Water Science Center in Illinois. So we'd have to fly them out to operate the vehicle and collect the data, but it's an option. What Jeff DenBleyker is referring to with Dave Nass, that was Dave strung a fiber optic temperature cable all along the South Shore, looking for temperature anomalies along the bottom sediment. And then he also installed some seepage, groundwater seepage I think that that's pretty much out of commission now, and it's quite old now. But I think it needs repair work, which isn't cheap.
And you're not going to get the temperature differential that you want.
Yeah.
Conductance probes from different providers to get the range in Great Salt Lake. From what I
Yeah,
remember.
actually, I think that's correct. I think YSI, Christine, correct me if I'm wrong. I think the
To you, and you put it in the lake, then you're going to have to throw it in a dumpster afterwards.
yeah, exactly. They actually did use that eco mapper for another Dave Naff's project where he put. Do you remember when he turned the Goggin drain? He turned that thing fluorescent green out with the YSI to measure fluorescence with the fluorometer to measure fluorescence intensity in the water column to track that dye. So it's been done. It can be done.
All right. Well, thank you. The big mystery is to.
And I thought somebody funded Greg Carlin to look at that. Anybody know about that? Okay. Maybe that was Friends of Great Salt Lake that mentioned it. I think they funded for groundwater sewage.
Okay.
Salt out.
Great. Well, so wanted to just touch on this framework because I think our objective here is to make sure we're asking the right questions. I think we've had some good questions have come up over the last few meetings. I want to make sure we're cataloging all those questions so we don't lose those. But then also take a look at that list and say which questions should we be prioritizing and working toward. Some questions are applicable in the paradigm we're in today, and some certainly are more of a long-term look. But if you recall, when we first set up our research framework, we had kind of 4 phases. First phase was really just, are we using the correct methods and thresholds, which then feeds into trying to understand the salinity characteristics and dynamics of the system, which then get us into more of a management paradigm where we're able to say, well, how can we manage if we should manage the salinity, or how can we do that, and then how does that connect with the watershed, and that's where we're really in this a management paradigm. And when we look at the first phase, the red boxes are where we think we've completed that work. The orange boxes are where we've started work or are working on them now. And really, again, this first phase is really focused more on the monitoring to get to a point where we can assess our current status. And so we looked at ongoing monitoring. We looked at some of the ways that we calculate salinity. We looked at what the designated uses are so we can try to get to an assessment tool. And I think some of the key results from this work were really the round robin. We have an SOP, standard operating procedure for how we measure density in the lake. I don't want to say we've already got a completed equation of state. It sounds like we're well on our way to answering that question. And then just recently, Division of Water Quality has a new sampling plan, which is the key goal was to try to capture the ongoing monitoring, make sure we're doing the right things so that we can, instead of relying on the Union Pacific data that they were required to provide, that we can maintain that data set going forward. One of the questions that came up just in the last couple months through feedback was just the ion composition of the lake, keeping an eye on that. How has that been changing? And then what are the overall budgets, for each of those different ions in the lake? And I think that, which Andrew, UGS has been tracking a number of these over the years. There's some new ones that have come up that are of interest. but that was a question. I know, Andrew, we've been working on, the challenges with, the laboratory side of it.
Yeah, I don't have any meaningful updates. There's just a bandwidth problem of tackling that. Other than Division of Water Quality, is anybody else? Well, so we actually just did a sample run where the USGS is sending duplicates of our samples into their lab, so we should see how that compares. So we're doing a few small things, but not really anything meaningful to get towards a standard procedure for measuring ions. But
I think we've been talking, Mark, a little bit about the mineral extraction industries to see, are we measuring these consistently?
So the challenge is you got to pump to get a fresh sample, and that's not happening right now. So we're not taking anything new. We get some elevation, maybe.
Well, how are those being measured? You're doing ion chromatography, those groups, or?
Optical ICP and ion chromatography for the cations.
Okay.
We've used a variety of different commercial labs. We do the density analysis. We send to commercial labs.
Okay, so you're getting a sense of agreement between different methods. It sounds like. Yeah.
Not yet.
Okay.
I'd appreciate a conversation with you about some of those.
Yeah, but you can do both anions and cations by ion chromatography compared to ICP.
Yeah, that'd be interesting. So,
yeah, there's options.
I think that's the question is, are we doing it the right way or the best way? Is it consistent with what different companies are doing? So that
most of the labs we've talked to, they all do optical ICP for that.
It's very quick. Yeah.
And it's been hard to find. I mean, we've tried a couple different, we've tried some labs that specialize in geothermal brines and some more research-oriented labs. It's just the results have not been.
I mean, that's why I'm worried about the optical,
exciting,
right? You have all these spectral interference. So, yeah, I think we're talking about it.
So I think, but I mean, when we look at phase one, there's a lot of completed boxes there, and that part of this. In phase two, what we wanted to do is really look more at the characteristics and dynamics that drive the system. And here on the right-hand side are me compressing the questions quite a bit there. But one of the key areas was with the database, and I know Christine gave us a report last month on work USGS has been doing to integrate some of the different databases, validate the data sets. The new sampling plan was completed, certainly in part to try to streamline monitoring efforts on the lake and coordinate those better. In terms of the salt balance, we've had a couple of different efforts that have been done to kind of reconstruct the salt balance, and whether Bill, work that you started or had completed, and Christine, work you've been doing, and I know you said that you've gone back to 2011 to reconstruct that. I think back to the database, one of the questions that was asked was, where should future data reside? We're creating one database, where should that be? The USGS has a data set. I know UGS has a long-term data set. Is there a way to just make sure we've got a plan going forward as we try to integrate those? On the salt balance side, there are some questions that came up on the amount of salt that's in storage in the north arm crust, as well as the evaporation ponds. Kind of getting at the question I tried to set was, what is the total salt mass us? How has that changed in the past? And then, the north arm salinity dynamics and the water column and characteristics. I know Andrew, you and Elliot have been looking at that. Elliot has a study that you guys have a few studies that you've been doing on that. But then we look at the south arm. How is the salinity mass balance been changing, and why has it been changing? Flow through the causeway fill. We were just talking about that. That's a question. I think I'm getting ahead of myself a little bit here. So this, I think, is potentially a new project, and one that I guess we didn't have on the list, but I know UGS has been working on through some hot topic grants. So I just added a box there, and then the salt dynamics.
Wait, Jeff, can I ask a couple questions? Yeah. So, I have memories of being shown some really cool things. Like you guys did that. I can't remember what was on the axis for this plot, but you could see how the regime changed in terms of salinity to relationship to, I can't remember what exactly, but they did a nice analysis. Is this stuff ending up in a repository somewhere where we can go back to it and refer to it? Because it's got to, in my opinion, it needs to accumulate somewhere.
Right.
Data is great, but most people don't have time to go back to raw data and try to figure out what it says. They usually cheat by looking at the reports or papers that came out too. You have to work with both. So if we could have a repository where all these reports and things, papers reside, so we can get to.
There's been a request for this for years.
Okay.
I think Jeff kind of hit on it, and Andrew, it's just, there's bits and pieces at UGS and USGS, and we have some tech team grants should be published to our website, and you can get stuff there, but there isn't a one-stop shop for all Great Salt Lake research, and we were thinking that this may be a point of discussion to have with the new strike team, because they're also talking about Great Salt Lake research and what's out there and what isn't, and so I think the time is now, and there's probably money now to have something hostable, because before it was who hosts this, how do we pay for it? It's an ongoing thing. It's not just a one-time thing and you put stuff in there and it's done. It's just it would seemingly take a bit of work. So maybe we can have a discussion about that.
I mean, it could be obviously just making the directory on box is a little too simple, but even doing that would get a long ways towards getting this material somewhere people can get by.
I think we would be open to having conversations about that in the future, but who's best to host that? I don't want to redo what Andrew's already done.
UGS, right?
Yeah, I think so.
It's getting an option.
Well, I think the UGS would definitely be open to that.
Yeah, I know the round robin memo that this committee did, the SOPs, we published those into the UGS system so that they're there for time memorial, so people can access it, find them. But I agree, and that's been a question. Wally Gwynn had his extensive library that he had on CD-ROM and in his book, and there's a lot of information that's been done. And
I have a hard drive. He burned me a hard drive. If anybody ever wants to plow through any of Wally's stuff.
I think one of the challenges that we've kind of grappled with is that you have to be searchable and queryable by people want to know by author, year, subject. So there's all these end up looking a whole lot like a database that you see at the library, university.
Yeah, no,
in my opinion, there's so much research.
It's just you don't want the product to be the enemy. Good, right? You have something.
I think this is something that we ought to push for, maybe even this year. With there's tons of one-time money, and perhaps there's somebody who could champion the creation of that database. But that's certainly something that we've been talking about.
I think usually there's people who write issues, and some are published, in journals and whatnot, and then it seems like about that point it just, you don't hear about it anymore. And I don't know, surely there's librarians who know how to work that kind of system, but I don't know. But I
And
think
you
it's a
can put
need.
placeholders for publications that aren't still copyrighted, following copyright distribution rules. You can put placeholders for those in there and even links, right? But the stuff that's harder to get is reports and things that are down in somebody's.
Good point. Well, that's a great one to add to the list.
Maybe I'll just make a pitch. If people have data that they want to publish, we do open file reports. So if you want to get your data in a permanent format, you just,
Could you
I'm not
put
sure,
all the tech team final deliverables in that?
potentially.
That's a good idea.
That's a great thing to add to the list. Sure. We don't want to repeat what we've already done, and certainly that would help. I like what you said in terms of it can help us focus our efforts on addressing the new questions rather than having to go back through all the raw data each time. So I think some of these other questions, salt precipitation processes. I think Tom had asked a question about that, and my interpretation was, well, as the salinity gets higher in the south arm, do we know when we might start to see salt precipitating? Is that settled science, or is that?
I mean, I think we do based on what we've seen in the North Arm. I think we have a pretty good idea of when things start falling out. I mean, there's some seasonality and complications like that, but I think we have a pretty reasonable idea.
Okay.
When things will happen.
And then what can we learn from historical shifts? And Craig was just asking that, is, we want to be able to recreate what has happened in the past. We need to be able to do that if we want to adequately forecast what could happen in the future. So as we shift into phase 3, here we're really starting to get into the management, and some of the questions that were in the list that I think we played with a little bit, but how can we integrate all of these processes to understand how the system works together, which factors have the most influence and at what time scale, how might salinity change in the future, how can we manage in-lake salinity, how does saltwater removal, so I presume pumping saltwater out of the lake, influence salinity. We're not only removing water, but we're also removing salt out of the system. Should something be done about the deep brine layer? Sounds like maybe we don't have a deep brine layer. So maybe that's not as relevant today. But I think, and so this was kind of the conceptual model that we had was, if we have a data set, we have an understanding of the salt balance and salt dynamics, how can we start to make some adaptive management decisions? And so some of the things that we'd identified previously were, developing a user portal or some sort of a dashboard, and that advisory council funded that, and USGS developed that this last year. Updating the bathymetry of the lake to incorporate some of the latest LiDAR data. Developing a scenario planning model and evaluating management options. And certainly it's what Water Resources has been doing, working on, and in tandem with the model Sam has been working on up at USU. So really trying to identify, well, what kinds of options do we have? And I think that process worked very well over this last year, where we made modifications to the berm in response to what we were observing. But I think a key question that we've touched on, but really what are the implications of these changes, of these options that we have? You know, as we, and Tom asked this question at the last meeting, you know, we identified the berm as a management option because we saw salinity coming up and we were moving into that threshold, you know, outside of 120 to 160 grams per liter in the South Arm. And so we saw that happening, you know, we implemented the berm option and yet, you know, we're seeing salinities still going up. And, you know, and so we're moving into, you know, I guess not potentially anymore, we are in a new paradigm in the lake. And so what can we do about that? But also what are the implications of that and trying to understand. But
Did you say that, you know, we implemented the berm, that the salinities are still going up, but of course they're still going up because that reservoir of salt in the deep brine layer has now mixed, right? We saw that back in 2014 and we're seeing that again. And so the sad fact is we didn't stop the deep brine layer soon, right? To avoid the problem. And so, so that's not surprising. Still going up. That's not a mystery.
Right.
And so from here on, it'll go up because of evaporation, but that would be a different process driving it relative to this mixing process. So what I'm wondering is this getting reported? I mean, is somebody developing some kind of publication report about this evolution? You know, where Craig made the very good observation when the causeway was closed, we got a 3-foot differential, and the only way you can explain that is if you got a good seal in the causeway. That's an important conclusion to draw. That okay, the causeway is no longer considered, at least infiltration through the causeway is no longer considered a major transport mechanism. We got to report that, and lots of other things like this mixing of the deep brine. The deep brine layer as a reservoir of salt in the South Arm needs to be reported. We published something that gets somewhat there, but I'm just wondering if there needs to be a more formal, okay, it's time to create some kind of product in all this so it gets recorded, because otherwise you end up running over the same terrain again and again. And so it's like the repository, but also like, okay, trying to make a report of somebody.
I have a monitoring plan that covers some of the reporting that you're talking about.
I'm not quite sure because that's quite a bit of interpretation to kind of get into these dynamics.
Yes,
but I will say, Bill, that we had a topics grant funded last year and we're digging into these questions, and I'm not sure exactly it's capturing everything you're mentioning, but it's what percentage of the salt mass in the deep brine layer and how did that change in response to causeway condition, and how did the salt mass evolve in the South Arm under different conditions. So we get at some of those things and we are planning to jump in.
Okay. Okay.
I think that gets it.
So it sounds like, you know, the different agencies have enough motivation to create the products that are needing to be created.
Yeah.
Okay.
Yeah. I think that's, I'm sorry.
Question with respect to that. So with mineral extraction companies, like I've been to Compass where they flush water back into the lake. I don't know if that's still happening, but if that's salt water flushing back into the lake, does that counteract what's going on at the breach? Because we're essentially forcing concentrated salt water back into the lake, and is that something we should not do anymore?
Well, they flush, what they told me is they try to bring about 5 million tons of salt back from their west ponds to the east ponds. And they try to flush that out with Bear River water every year. They've got less water to flush it out with. And so, and they claim that they've only been able to flush out 3 million tons a year. But if Christine's estimates are right, that's just a drop in the bucket.
And that water that they flushed that with was going to the lake anyway, or would have gone to the lake. It's a diversion through the ponds. So that
It would have gone to the lake as water from the Bear River. So the question is, are we bringing more salt into the system?
exactly. Yeah.
And you're saying it's negligible.
Well, I'm not saying it's negligible, but it doesn't explain what we see. I mean, there's something else going on too.
But what are we seeing exactly? What are we trying to explain here? We're trying to explain the difference between a salt mass balance and a model.
Well, we're just trying to explain the difference between a salt mass balance and measurements. So the measurements indicate you've got hundreds of millions of tons that we can't explain appearing in the South Arm. And, you know, we can explain parts of it with flushing water, and but really, overall, the total amount of salt has been going to the north through that breach.
But
And-
that's what the model is explaining.
No, that's what the measurements are explaining.
Well, what measurements? The salt mass balance, Christine, or the measurements that are used to create a model, and then the result of the model would tell us that we have export from the north to the south. Whereas we think it's the other,
So-
better get that one right.
Exactly. Yeah,
Yeah.
and that's what we're trying to just reiterate one more time. Because the problem with the breach and the challenge with this whole analysis is that we have salinity and we have volume in the South Arm. And so Bill and I, you know, we did this comparable analysis, and I think we're fairly confident that this mass increase in the South Arm is real. I mean, I'd be open to other ideas on that, but the challenge with when the opening in the new breach is we have a flux of salt moving from south to north and north to south. Our measurements are monthly with flow, and bi-monthly every other month, sometimes monthly salinity. So the challenge with that is we know that that site is very dynamic. There's such events, there's lots that we're not capturing with these discrete measurements. But what the measurements are showing, if we take a very simple analytical approach, is that we're estimating more salt mass is actually being exported to the north and we're importing into the south, which means that the North Arm is not accounting for the increase in salt mass in the South Arm based on the measurements we have. Again, we're limited in what we can analyze there because it's so hard to collect these data, especially real time, which is why another idea we've had is to work with SOM and try to get an actual model discharge, daily discharge at the breach using his model to try, because basically all I'm doing right now is taking a linear interpolation between flow at one point in time and another, which is month to month. And I'm fully aware that that does not capture all the dynamics that we know happen. So another thing we're going to try is using some estimated daily discharge there and see if we can get a different estimate. And I think you're right. It's critical to get that piece right.
It is,
So
and there could be different hypotheses, right? I mean, the hypothesis could be there's inflow of salt into the South Arm that don't know where it's coming from.
Yeah.
Saltwater springs, whatever. You know?
Mm-hmm.
But the other hypothesis could be that the measurements are maybe not correctly describing what's really happening.
Well, Thomas,
at the
you're right
level of the breach.
in a lot of ways, because they go out and measure the breach when there's not a lot of wind. So they're probably missing the wind events between months.
But I also remember Ryan saying something about the equipment that's being used to monitor that it doesn't monitor the lowest 1 foot or so of.
Yep, there's a blanking distance. So the uplooker, Brian, correct me if I'm wrong, but the uplooker does not, we're not measuring what's happening at the lowest depths. And I think at some point, Sam had said there could be supercritical flow based on the physics of it or something. And anyway, we would not be able to capture something like that.
So just to chime in on that particular question, the blanking distance. So that's correct. The instrument doesn't measure velocities all the way down to the bottom, but we have a Hot Topics grant this year to get us a new uplooker velocity meter. The one that's there now measures of 10 locations in the water columns. The new meter that's being purchased with Hot Topics and USGS funds is going to measure at over 250 points in the water column, but it will still have that blanking distance because it's basically the part of the water column taken up by the instrument itself. It can't measure, it can only measure above itself. So we're combining the uplooker measurements with when we do periodic visits to make discharge measurements with actual physical measurements of velocities using spinning cups. on really old school water velocity meters. So we're only able to do that, when we're there in person, but we're able to lower that instrument all the way down to the very bottom to get a complete profile of water velocities. So that's data being collected now. By the way, the new UPRR velocity meter has not been delivered by the manufacturer yet, so we still have just the old meter measuring at 10 locations. But this just gets to the idea, we're seeing the salt mass increase in the South Arm. You guys are all onto this. This could be an artifact of the measurements, uncertainty, or what's the porosity and permeability of the railroad causeway? What's the salt? Craig's played around with that a little bit with his modeling. But yeah, so it's about tightening up uncertainty at the new breach, and then asking ourselves, is there any other source? Is it just water draining out of the newly exposed lake? As the lake level drops, water is moving from bottom sediment down to into the lake. So there's still many questions to be answered, but I think we're on the right track, right? We're getting improved instrumentation, we're making visits, et cetera, et cetera.
Well, and 100 million tons of salt is not moving as a dry product. So it is a brine with 100 million tons of salt. That would be noticeable. So this is probably an exercise in crossing things off the list, saying it can't be this, it can't be that, or like you say, trying to refine things to where we shrink that overall error band. That's a lot.
I mean, the problem we have is that we have two data sets that are not giving us the same result. And we don't know which one is right or wrong, and we don't know, they might be both wrong.
Can I ask Andrea a question about groundwater? I know it's not your thing, but I know, talking to Jack Oviatt and others who've worked out at Bonneville Salt Flats, there's a possibility that salt didn't come from Lake Bonneville, but instead was ground fed by brines. And I'm curious about, I always think of groundwater as fresh water, bringing some divalent cations and so forth, particularly calcium that we see evidence of in the carbonates. But I'm really, really curious about the possibility of groundwater bringing salt and being brine rich instead of fresh water. And that's not the way I think about it, but because of these conversations I've had with Jack, I've gotten really interested in that possibility.
Well, I think if Elliot were here, he would have something much more intelligent to say, but I think that that's definitely something he's wondering about, something that we're looking at more anecdotally than quantitatively at this point. But
I'm just, now that all these groundwater pools are appearing around the lake, when I'm measuring salinity of them, they're highly variable.
yeah, I think we're seeing the same thing.
Yeah, so it seems to not be the same source every time. Or it's coming through something that is contributing minerals.
Yeah, the groundwaters on the east side of the lake are all very old and undergone a lot of water rock interaction, so they are salty.
And briny. So I just wonder about that as a contributing factor.
And that's what I think Greg Carling's looking at.
Yeah, we've had some talks about that.
Doesn't Simla have a lease for lithium out in the West Desert? That could be a good indicator of like what they're actually pulling from the groundwater in their that industrial process.
Trying to think of the civil lease.
Maybe something you might be talking offline about.
Okay.
I think they're pulling groundwater, extracting lithium out there, and that might be a good indicator of, depending on which way it's flowing, it's coming from the lake, feeding the lake, what's being fed through the groundwater.
But the other source of error in the salt balance is, depending on how well you can take into account the deep brine and the fact that it's a transient when that mixes into the lake, that can mess up your comparison.
Right.
Yeah.
Yeah. I mean, it's like, because we're, from the measurements we have, we're saying, here's the deep brine layer interface. So we're just extrapolating that across the whole, the whole lake, wherever that sits and interacts with the lake bottom. But There's
Yeah.
many answers. And we just don't have the data to really inform anything better, I think, is where we're stuck.
Right. But getting this out here as an analysis would be great.
Yes, and then just listing all the uncertainties very clearly.
But I think, Bill, to your, I think your first point on this track was just looking at, trying to understand the story of what we already discovered and making sure we document that. I know in those last 6 to 12 months, we've had lots of questions and there's been a lot of work that's happening. I don't know how much of that's actually been written down.
Would it be worthwhile to take this framework and have just some sort of narrative document with short answers and references as we kind of proceed through these discussions and meetings?
Yep. I started that on that list of that original memo with the questions, and what I just sent out last week. And Christine had, color coded the questions. So here's what I think we've done, here's what we're working on, here's what we haven't. And I started putting some references in. I think that, especially for the things that we've already done, that would be valuable. So we can track that. But I think, as we look at the implications, to designated uses, I think there's a lot of questions that go into that too. I mean, even with some of the proposals that are being made,
Where'd that come from?
bringing in saline water to the lake, I mean, what are the ions, as compared to the lake? And
So
there's
we
lots of-
are a saline lake, which means our ion concentrations mimic that of the ocean.
Yeah. That's sort of inquired.
I'm gonna get the word wrong. I have to see it to say it.
What's the name of it?
Hang on a minute, I'll tell you. Come back to
I'm
me.
gonna write that down.
Is our calcium too low though?
Calcium is not overrepresented in the ocean, but the lakes that are inland that were not ever connected to the seas don't have that same, like the Dead Sea is very divalent, right? A lot of calcium, a lot of zinc. And so the lakes that are high in sodium chloride sometimes are ones that were formerly connected to the seas and have that ionic distribution. And so in salt lake studies, there are 2 types of lakes. If you give me 1 second, I'll say the word right. I don't want to mess it up.
I've never heard that word before.
It means sea. It has a root that thallow means sea. Hang on a minute. Talk amongst yourselves.
Well, just related to that, you've seen the work that Dave Nash got involved with Blair Jones as an author and shows those geochemical divides that lead to these different outcomes in terms of water chemistry in saline lakes. You guys are aware of that.
Yeah, Elliot knows a lot more about that.
Okay, so that's going to be really relevant to that discussion. What would happen to marine water right?
Thalassic, THALASSIC. Thalassic lakes such as Great Salt Lake occur in association with oceans and have similar proportions of salt as in the sea, while athalassic water bodies such as the Dead Sea have no marine association. I wrote that, I should remember that.
Well, so I think where the questions, the discussion we've had over the last few meetings have been, certainly what's the future status? If the lake continues to go down, and that shifts into, phase 4, where we're starting to talk about the interactions with the watershed. What is the future disposition of the lake? How do reduction? And we had contemplated that in terms of linking the work that the Salinity committee is doing with work that Water Resources and others have been doing, just looking at changes in hydrology of the watershed, and how did those changes of inflows affect salinity in the lake. And, you know, we did have some questions with regard to Farmington Bay and Bear River Bay, perhaps not as relevant now because they are dry for the most part. They're rivers rather than bays. But certainly would apply if the lake and when the lake comes back up. So I guess
Can I throw another question in there?
Yeah.
Which, you know, I think everybody's been dancing around, which is, you know, what are the downstream effects of terminating flow into the North Arm? Isn't this the committee that would actually be the best to explore that question, or is there another?
I don't know that
I mean, you threw a bunch back at me the other day, so I thought maybe there was.
Well,
So
there's there's committees, there are people looking at the upstream side.
Yeah. No, that was useful. That was.
We kind of looked at that today. Somebody asked some questions about that. So you're asking what would happen if you just cut off the North Arm?
Yeah, I mean, I think that's worth exploring.
I agree.
Yeah.
Comes up all the time in conversations now. with
So it probably,
legislators and
over a 6-year
policymakers.
period. Wow. So we looked at that with, if you close the breach, it'd probably affect it maybe a foot or two over a few years. So
But that's over a few years that you had 700,000 acre feet of inflow. What if you do it over the last 5 or 10 years where you had 1.3 million acre feet or so of inflow?
Well, we ran the experiment. Yeah, we did during the low flow. We just looked at that plot.
Yeah.
There's a differential of 3 feet.
That's
So
exactly what I was
in a
thinking
few
about when you
years.
said that, was what if we cut the North Arm up, took that elevation to the south arm?
Structurally, can the causeway function as a dam?
Yeah, it did.
To a certain point.
And the point is, it doesn't have to be all or nothing. How much do you restrict it?
I wonder if that'll be a question that comes out of this next legislative session or something that we're required to take a hard look at. Maybe we preempt that.
Well, the railroad, when they did close the breach, they should have done the math to determine what they needed or what they could survive from a maximum differential to sustain their commerce. So that ought to be somewhere.
I think they did that engineering.
Should have. When you're building on
Did you
a,
leave
you're
it
building on a
as-
lake bed that's 70%, you know, the clay is 70% water. I've seen it move hundreds of feet of dike, just slide away.
Don't
So
you
we
have
just need the
Dutch
right
ancestry?
differential.
Could you call on some people to put their fingers on
See
it?
if I can
You
channel
should
something.
know, yeah.
And a modeling background too.
Yeah, right. Let's get the Dutch over here to dike this thing.
The guy that puts his finger in
Well,
the
use your fingers.
That's this guy.
Yeah.
Bill, the net effect would be that they're struggling right now to get brine out of the lake. So if you drop it by closing off that flow to the north, it would make life even more difficult.
Or it would, but if you don't, you might end up with nothing. I mean, that's the flip
Nothing in the
side of
South
that
Arm is
story.
what you saw. Say
Half a lake is
Nothing
better than-
anywhere.
Say again?
Half a lake is better than no lake.
He
Half of the lake
speaks
is
for the
better.
birds. He speaks for the birds.
Yeah.
Well,
No,
it's-
anyhow, I'm just thinking of this.
And you're speaking in terms of compass.
Yeah, I'm just speaking in terms of compass
And
memories.
but there's US Mag, for
Yeah.
example, the brine shrimp.
Maybe they can start getting their water from the South Arm. Who knows?
Maybe. Yeah, I mean, that's an interesting area.
Just another explorer thought on that too, but I think the Corps would have something to say about completely backing it off. I think it's worth looking into, but I don't think that their permit would allow it to be completely banned. That was something that we briefly discussed when we were looking at the permit and what was necessary to alter the berm. And I think that was kind of a contingency, as long as it's not completely blocked. They would require us to get a new permit.
Is that because of the truss? Because of navigability?
I think navigability plays into it. I don't think they're looking at
That
it
wasn't
necessarily
theirs.
through a public trust lens, but navigability is part of it.
I think it's just change of use,
Exactly.
of navigable waters.
Elliot showed me a picture that looks like that's kind of what they're doing now, is taking South Arm water instead of North Arm water.
So
But without talking to Joe, I don't know for sure.
I was actually going to mention this as well when you were talking about flushing of the ponds, and I didn't want to speak for Joe, because I'm sure he would be able to speak more intelligently to this, but I'm sure you're speaking of the extension of their canal that was on the south side near the causeway.
Yep.
And I think that that is actually pulling brine they used to flush their pumps on the north side. So they use the saltier south arm brine to flush those pumps, and then they also use the south arm brine to flush their ponds. And so they're not, but and I meant to say that because they're not actually going to do that this year. They're not able to reach the brine. So this year might be a good year to see, how things are impacted without the flushing of the ponds, because normally that occurs about this time of year. So this will be interesting to see if there's maybe some of those unexplained salt balances might be able to be slightly more explained.
I am concerned with all the digging they're doing it right through microbial fields. And that needs to really be addressed.
It has been. We weren't aware. They also, I hope you weren't aware that someone was out there dredging. Because from what I understand, it's supposed to be a hydraulic dredging on the contractor misunderstood, or there's some miscommunication.
It was an accident,
But they're resolving that with the court right now.
yeah.
Well, I mean, it's a good question.
Yeah, I have a suggestion, because I think all of these questions are important in the long term, but in the short term, we have a crisis, and shouldn't we try and identify what the priority questions are here, like the one that Bill is bringing up? I brought up this question mark about what is the amount of water that we really need on a yearly basis, or at least a differential just to maintain lake levels. We think it's around 400,000 acre feet a year, but we're not modelers. It's not our expertise. So it's very indicative. And the way we came up with those numbers was looking again at historic data, because we can't model, so we can't look forward. But that's what it's indicative, and we're happy to present it. Maybe you shoot it down and say we did it wrong, and that's fine too. But to me, that's a real question, because with all the changes that we've had in last legislative session and 1-2 years ago, it's sort of long term. Can we get more water to the lake? At least we've got a legal structure that we can now do it, but how much can we get to the lake?
Yeah.
And then to look at, how much do we need? And that should be at least indicative of, what we can or can't achieve in terms of getting more water in. And then we need to look at other options. Anyway, in my mind, we're in a crisis here, and it's nice to look at a bunch of questions, and ultimately I would agree that they need to be answered, but my feeling is that there might be some priorities here that need to be answered first.
Well, if you look at what's easier, you could maybe, if you really try hard and you dry up some farms, you could get another 400,000 acre feet of water to the lake. Or you could maybe dike off like 17% of the surface of the South Arm. I mean, there's things we haven't looked at very effectively, but this is the time to start looking at it.
So we have an existing dike. That's an easy one, but we have sort of two basins in the South Arm, and so there's that spillway and sort of that, and maybe that could be used. I don't know if that's what you're thinking of, Craig, where you could say, okay, you could dike that off. That would be a big project, but might be cheaper than.
You're probably going to get that pipeline finished when your grandchildren are age.
Gotcha.
But
how long did it take to put in the causeway? Was it only like?
It wasn't too long.
It wasn't too long. No, I seem to remember that.
And another factor that's affecting things and we're trying to get a project in place to actually measure evaporation and get a good model of how Great Salt Lake evaporation occurs. Because right now, evaporation has always been used as a calibration term. Oh, the elevation doesn't quite match, so we feel the evaporation, and really we don't really have a clue as to what drives evaporation. And right now, when you have changing weather, that's something we really need to tie down.
Yeah.
Very effectively.
And is this the strike team talking about this, or is this?
Well,
who's talking about that?
this is a side conversation, and eventually we need to bring it up in strikes.
Because the stratification, with USGS was shown that, you end up with that pressure water lens on top during runoff, and that's probably a high evaporation layer that you can't think of as a fully mixed water column than saline water evaporation. So being able to account for that is going to be tricky. Comes down to the lack of data.
If we have another dry year like this one, we're gonna hit 22%, somewhere in that range. I can tell you that the RLC right now is hitting 22%. The brown shirt population in the RLC is about gone. I just talked to Professor Sorgelos about that a couple of weeks ago. He was there, so they've been monitoring that. And I'm just giving some information here. I think we've got a crisis going on with the microbialites already today. In brown shrimp population, we're still, I think, surviving, but maybe not that long. So, I would love to know the answers to all these questions, but sometimes we have to live with the information we have and try and come up with the best possible answer. And I don't know how we get to that, because I think we're in a crisis. And I don't think we have another year to make decisions, if there are even decisions to be made.
Right. So it sounds like, that's the perfect segue into what are the questions that we need to answer. Because there are a lot of questions. I think it's useful to understand what we've already learned and, where the gaps are in the science and, in our data sets. But in the end, what we need to do is we need to look at, well, what's the outcome that we need to address? And because, like you just said, we may not have time to really build this up from the bottom, to get to that final answer. And so I think we want to have a list of these questions that would help us identify, well, how would all the different pieces of the puzzle, help get to that final answer. But we need to make sure we're asking, what is the question? What are those key questions that we need to answer at the end of the day? And so I think there's questions of, well, how do we get water to the lake?
Right.
And those are the ones that I think the legislature has been focused on.
Right.
How do we find water to get to the lake? But I think what this committee can certainly do is focus on, well, what's going on in the lake.
Right.
And certainly, the crux of it is the salinity of the lake, of what we're observing changing. And so what are, we last year, we identified what the key thresholds are and what the potential implications are. I think as a committee, we talked about, well, here's the key concerns of if the salinity keeps going up. We've got that matrix that shows it. I don't know that we put together a position saying that, like you just mentioned, if the lake does get up to 22%, here's per our matrix, here's what happened. But then also, I think some examples looking at other systems that have achieved that, or even Great Salt Lake, at 22%, what does that look like?
Yeah, and Jeff, that's the terminal. And I guess what I'm hoping we do as a committee, because there are representatives from industry as well as regulators and scientists, is that we're now at the point where we can talk about the spatial aspect of this, right? Because we've got those salinity ranges, but they don't talk about, okay, so where are we going to be examining that impact, right? And I think, understanding, okay, there's two mineral companies, there's brine shrimp cooperative, there's other uses, and there's the dust issue. How do you optimize the use of the water that gets to the lake to honor all those needs, right? And, I think that's what this committee should be looking.
What options do we have to manage it? And I think this I mean, we have elements, I think, of all of these. We have, and they've been using GSLIM to look at the salt balance, the water balance, look at some of these questions. What if we do cut off the north arm? We've got, and the Water Resources is working on the watershed models. So I think we have those pieces. I think what would be helpful perhaps to drive the further development of those models, and more importantly, to use those models to identify options, would be to make a list of what are these ideas and what are these key questions or what if questions that we can start to go down and check them off and say, what if we close the breach, or what if we built a dike across that spillway to cut off the Carrington Bay. What if we built one from Fremont Island? And there's a lot of those things that I think we can, until another committee is formed to do that more specifically, is to start building that list and identify, I guess, help Craig. I can only imagine how many phone calls Craig and your division get with ideas, or Laura, with ideas from people, what are these ideas and how can we prioritize these ideas so that their time is better focused on, would that be helpful?
Yes, yes.
So Tom, to answer your question, what would happen if we closed off the breach? We lay low,
It's actually Bill's question. I'm just.
Bill's question anyhow. Director Ferry was asking all kinds of questions, and so we had Layla, our Great Salt Lake modeler right now, run all of these scenarios. And if we had the piss poor inflows that we've had for the last ever since January of 16, it would increase the elevation of the South Arm maybe half a foot. So,
Based on what we've seen, I don't buy it.
yeah, well, it does seem low to me. I'm gonna have to go in and take a look and we'll have a little talk with Layla about that. But
Get her to tweak some knobs, turn some knobs, fix that. She should be able to produce. She
Not
should be able
acceptable.
to refind out.
What number do you want?
Yeah.
No, she should be able to reproduce what we saw when the burn was.
well,
when
when the
cover
burn was closed, we had higher flows too. So.
No,
The other thing the other issue is we were at a different bathymetry.
but and that's a very good
Bathymetry because doing ATV surveys on the
Yeah,
west
that's
side
very
this spring, there are expansive dry areas that were water last year. I mean, I'm talking miles.
No, that's a good
Yeah.
point.
Anyhow, it does look funny to me,
So
but that's what you
bathymetry is gonna.
Yeah, but that would make it convincing is if she shows, okay, I can capture what happened there, but this is why it's not going to happen here.
Yeah.
That would be great.
But you would want to look at it, I think, Greg, I'm not sure, but I think you would want to look at it during different time periods, the last 5 years, last 10 years. Look at what the average inflows were, the last 20 years, which is our drought cycle, right?
This is what we could do overnight.
No, it's awesome. Yeah, it's great. No, but I'm saying,
Yeah, no, we should. Absolutely.
I'm gonna play devil's advocate real quick. So you're talking about diking off the north arm instead of the south arm. At what point do people upstream talk about diking off Farmington Bay, Bear River Bay to save wetlands and the uplands?
Oh, the real estate.
Because if you
Oh.
get it to where, say we come up with a way that.
And that was another question he had.
Yeah.
So if you dike off Bear River Bay to save the uplands and don't allow any flow through, you'd lower the Great Salt Lake South Arm by gads 5 feet or more.
Right. But I mean, that's what I'm saying. Is there going to be interest upstream that, well, you guys were able to do this to save this portion. Why can't we do this to save this portion? Are we setting ourselves up for?
Well,
Well, yeah, but I think what Bill says is really true, is that you have to look at all these uses and all the risks, right? I mean, you look at the dust production. If you can, and maybe you can, maybe the modeling shows that we can't save it, or we can save only a small piece. But then are you wondering, well, which piece should we try and save in order to mitigate dust? I mean, I may be wrong, but this is just intuitive for me. But if I think of the North Arm, I think of this huge crust of salt. And does that salt produce as much dust as the fine clay that we see in the south? I don't know, you know. But I do think that, like Bill said, is that we do need to look at all the uses. And it's not our decision to make ultimately, but it is, I'm assuming, our role to look at these options.
The other consideration that we've been hearing a lot about is diking off Farmington Bay, but making sure we keep Farmington Bay wet to decrease dust. So how much would that decrease the level of Gilbert Bay?
And I think for it to be a defensible analysis, is that all of those ideas need to be on the table.
Right.
And because you got to go through them and check them off the list and say, okay, here's the opportunities, here's the risks that each of these represent. So we understand what the consequences are. I mean, we're at a crisis point. Little Lake is extremely low, and we're seeing a significant change in the paradigm out there. But we also have to have a healthy respect that when we tweak the system, that there's ripple effects, and we need to make sure we understand them well enough that we can make an informed decision. We can't answer all the questions, we can't get all the science done, but we can compare them. And I think those are the kinds of things that I think this committee can and should do, is provide those kinds of, here are the critical questions that we see that need to be answered. Here are some of the options that we think should be considered. And so that can go into the discussions that, Craig and Laura and, you guys are in every day.
And maybe we should balance them against the ripple effects of not doing anything, which I think some studies have already been done on that based on other locations. GSLAC has done several studies, so.
Right. Yeah.
And how much leverage do you have, or latitude do you have, to develop the hot topics and grants around these critical needs, right? I don't know how much latitude.
You've got latitude.
Yeah.
Someone sends me emails that they'd like that as something to be considered by researchers. And then we have the subcommittee review the list of possible topics.
Okay.
That's a great,
because this committee could brainstorm these questions, and that can help guide
the advisory council could also contribute funding to look at some of these ideas too. But again, that's not any short term. That wouldn't happen tomorrow. That's like for next fiscal years.
Craig, unfortunately, I think a lot of these questions, these options come down on your group, to look at a lot of these what ifs, where we look at where we put water. But I think if we can prioritize, well, which ones does this committee see as the most important, then we can, hopefully that helps.
And I think you'll get better questions if you cross some of these things off the list, or at least understand contextually where they fit into the puzzle. We can spend a lot of time worrying about pipelines from the Pacific, but if you do the math, then you can figure that out pretty fast.
We have some relatively decent answers that can pass the red face test or the lab test. Like that is so much appreciated.
That may be good enough for most.
Exactly. Yes.
Have they brought up getting Snake River access water? There is. Okay.
Yeah.
Everything's been thought of. Okay.
Mississippi, Missouri.
Is there a list of all these ideas, or?
Nope.
Well, okay, Director Steed had a list of wild ideas. And All of my ideas were on that list.
That's something to be proud of.
It's been distilled down.
Can you guys share that?
Nope.
Why not?
I don't know. that
Because
it's
they're
a
wild
terrible
ideas.
point. Yeah.
I think some of them were totally ethical, so maybe they don't need to be broadcast that way.
They don't have to have names next to them.
Yeah.
Who can we say that they're from?
Craig Miller, right?
Great. Do you want to keep your job or do you want to lose your job?
Well, maybe, I mean, the Great Salt Lake Advisory Council posted an RFP way back and asked for, crazy ideas to get water to the lake.
And we got 72 of them.
We got 72 of them, and some of them were pretty outlandish, but they were ideas that were, and then the advisory council distilled those down to the number that they did further work on.
The 12, that ended up being the 12 water strategies report.
Right. And, and maybe that's something that, I don't know if it's the advisory council, if it's this committee or who, but, can, canvas, to get those crazy ideas and, out there. But I guess that's one way to do it. But I think more importantly with our time, I think, I think the next date for our meeting I had is December 8th, November. Usually we've been going every 2 months. But I think these questions are pretty pressing. This is a pretty important topic. And I guess what I would like to do is, I think that the questions that we had and we kind of went through today are great in terms of here's the science questions and how they fit together. But I think what we've just been talking about here in the last half hour has really been more about, well, what are our options to manage the lake itself? And I think if we can put that list together, and I guess I would suggest that we meet again in a month, beginning of November. But if we can all put our thinking hats on and brainstorm, ideas and come up with that list of, here's some key ideas that we have, and then potentially what are some of the key science questions that we need to address as part of those. Hopefully that would be helpful. I think Craig, and Laura, what would that be helpful for you?
Well,
Yes, I think
Yes.
so. So when can we have these lists?
Well, I guess what I would thinking out loud here, but if you could all, I can take what I heard today, some of these ideas I heard today. I can try to get these back out to you this week. Today's Wednesday, so yeah, it gives me a couple days to get that back out to you by Friday. If next week you all can brainstorm and and come up with your own lists of ideas, I think key science. So there's probably options for managing the lake. There's key science questions that would pertain to those. What don't we know that would affect that decision? Then you can send me your ideas next week if you want. I can keep them all confidential and just throw them into the pot and organize them.
You put draft on the document.
Put
That would be
draft.
really helpful.
And brain. And I don't know if we can classify this as a working, committee meeting, so that it is, confidential, so we can get the crazy ideas out on the table without any, those concerns. But I guess the goal here is we want to get as many ideas as we can. We want to, as a committee, be able to try to distill those down to the ones we think are the most important to look into, so that we can then hopefully provide feedback to the state as to here's what we think should be looked into ASAP. Here are the key science gaps that we have that maybe we need to start sampling the crust or putting piezometers out on the mud flats. I don't know.
Well, and I think it would be helpful for Craig's group to look at it and be like, oh, we have that answer. We've already done this, because
Yeah.
it seems like maybe there are a couple of answers that we already know, but is not out there yet. And so we give that information to everyone to review.
I mean, it's pretty amazing. Craig spent a day
I know.
and he gave us a solution to increase the lake level rather than decrease it. I mean, the South Arm.
Yeah.
I mean, I take an increase over a decrease anytime.
Just to help constrain things and not let the things balloon sort of beyond our scope. It's part of what we need to do, only look at managing from the lake as opposed to above the lake. That's a question. That's not a.
Well, that's been the effort over the years, is how do we get more water? As they've been looking at reaching out into the basin.
But as far as managing or salinity,
And I think this group, yes, I think just looking at inlake stuff.
okay.
I think if you have ideas or things like that, I think those are questions that we need to get to Water Resources, because they're going to be working on that. They've got a concerted effort to look at that watershed. I mean, and looking at the lake itself. But I think where the big gap is that there has been a lot of attention looking at what can we do in the watershed, all the legal and water supply bans, all those kinds of things.
Yeah.
Where we have a gap is what can we do in the lake.
I agree.
And I think, not to say that please don't provide ideas on the watershed,
Right.
but I think knowing that everybody has limited time and energy, I think what this committee could do to provide the most value is to really focus on what are those things that we can do from the lake to protect the beneficial uses of the lake.
Yeah, that's helpful, right? Because in other words, we're assuming that our current condition persists. What can we do to optimize the water that comes in? And one suggestion I'd have is you have to do it in some kind of hierarchical thing, because there'll be science questions that are common. Right. There's different overarching questions. You get to identify.
And then we can we can say, well, we already kind of know this one.
Yeah.
And here we have no idea, and then we can prioritize those two.
Yeah.
I mean, that's what I'd love to do exactly.
Okay.
Is to identify which questions are the most important that can get us to a favorable outcome. So I will get these notes together and the list of questions that we've identified out to you this week, and then next week, if you can all brainstorm individually, I guess if you want to get together, however, but by next Friday, if you can send me your list of questions, I will compile those into one list, a new document, and get that back out to you.
Good pace.
And then I guess that will give you a week, or I guess 2 weeks to think about it.
And Jeff, can I suggest that there be a fairly, we go for 2 or 3 iterations on this before the next meeting?
Sure.
Yeah.
So I can
back and forth.
So if you can get me all your questions back, I mean, it's a pretty simple spreadsheet exercise to cut and paste them all, so I can get them back to you all. And I can try to do a first cut at organizing them. And then you guys, if you can all review them and then maybe rank them as you see them. And then I can kind of try to sort those and see, well, which ones does the group see as highest priority.
Although we may need discussion for the ranking. In other words, if we can brainstorm and really fine tune the research questions that are underneath the overarching questions, come to our next meeting ready, with that real clear, I think we'll have good discussion about priorities. I don't know that I kind of prioritize without a group discussion, in my opinion.
Right. Well, let's see, I know I am out next Friday. So so I'll get this to you. If I could get something to you, if you can get me things by next Thursday. Otherwise I can get them back to you Monday. I'm just gone all day Friday. I won't have it. Okay, if you can get them to me on Thursday, I'll turn that around on Thursday to you all, and I'll also think a little bit about this a little bit better, so that we can what the next steps are before the next meeting.
Do we have a date for that?
No, that was my next question.
Get to you our management ideas.
Yes, and science questions.
You're gonna send an initial draft.
So that would be
Tomorrow.
Thursday the 20th or tomorrow?
Now
Question.
I'll get you a summary of this week, and then next week, Thursday, is when you would send me your list. So by the 20th, you would have me your list of questions. I would get that back out, compile it, and get it back out to you all. In terms of our next meeting, let's see, with November 3rd.
I'm out of town, but I'm sure Tim and or Phil be here.
Or the 10th.
I'll ask Tim. Phil, are you here?
What time is it?
1 to 3. We'll aim for November 3rd from 1 till 3 for our next meeting, and the goal there would be to talk about how to prioritize them and try to rank some of the questions. So Laura, November 3.
Okay.
I don't want to put a whole new can of worms, but has there been any action on making placemats out of the Salinity range chart? No?
No.
Saw that chart the other day and I thought I wish I had that placemat.
All right.
Who laminates things anymore? I don't even know where that occurs.
I know. Have heard of it.
Should have
I'm sure we can get
laminated a
it done.
matrix 10 years ago. I'll hear a couple copies.
So, all right. Well, anything else? So I'll get you this list from our discussion today, this week. Next week, Thursday the 20th, get me your list of questions. I'll compile them, and then we'll meet on the 3rd to talk through it. All right.
Thanks, Jeff.
Thank you, everybody.
Thank you.
Bye, guys.
Bye-bye.
It was good. Well, that was good.